Would a dilation alone be enough to show that similarity is symmetric, meaning that it can go either way? That is, would dilation alone prove that ABC is similar to A prime, B prime, C prime? Then A prime, B prime, C prime is similar to ABC. Consider the two examples below. Given ABC is similar to A prime, B prime, C prime, is a dilation enough to show that A prime, B prime, C prime is similar to ABC? We know that when we dilate from a point, like O in this case, oh my goodness, I can't with this rotation. The lines go through the center of dilation and the points that match up with the thing you're dilating. So, yes, a dilation is enough because the triangles are both dilated from center O and the extended lines connect O, A, and A prime, O, B, and B prime, and O, C, and C prime. So the lines connect all of those points, so they are corresponding, and a dilation is enough. This is for part A. In part B, is a dilation enough to show these are similar? No, a dilation is not enough here. Because a dilation only makes them the same size. We would also need to translate, rotate, and reflect to get them to coincide or match up. Then part C asks, in general, is a dilation enough to prove similarity is a symmetric relation? And then we have to explain. Based on A and B, a dilation was only enough in the first case, but it wasn't enough in the second one. So in general, is it enough? Not in general. So no, in general, a dilation isn't enough. In some cases, it will be, but in other situations, you will need rigid motions, also known as transformations, to map the figures onto one another. To get them to coincide, you will need a dilation and some of those rigid motions, and in other cases, a dilation will be enough.